Okay, so what we're going to do is conduct a between participants Anova, and we're going to explore age and gender differences in attitudes to homosexuality. We have our age and gender variables here, and what we've done is we've summed the items to create a total attitudes to homosexuality variable. So before we begin our analysis, we're going to explore the data. We're going to check that the data are normal. We're going to look at group sizes and get an overall picture of what's going on with regards to normality, because Anova is a parametric test and there are certain assumptions that have to be met. So to explore our data, we're going to analyse, descriptive statistics, explore. In our dependent list, we put our dependent variable, which is the total attitudes. And in our factor list, we enter gender and age. We click on plots because we want SPSS to produce a histogram. And we click normality plots with tests, which will produce the Kolmogorov-Smirnov test. Click continue and OK, and then we look at our output. So our output appears, and we can see here, looking at the case processing summary, that we've got very much unequal group sizes, which can cause us problems down the line. With Anova, one of the assumptions is that the group sizes are equal, and here you can see we've got 36 males and 90 females. So already we are noticing that there potentially could be a problem. In the descriptive statistics box, there's lots and lots of information here. Basically, we can look at the mean for males, the mean for females, and we can see that the means are slightly different, but really we don't need to pay too much attention to this table at the moment, because we're going to assess the normality of the data by looking at two sources of information. The first one is the Kolmogorov-Smirnov test, and the important thing to remember about the sig or p-value for this test is that if our data are normal, in other words normally distributed, we would expect to see a sig or p-value greater than 0.05. Here we can see for males we have a value of 2, and for females we have a value which is actually less than 0.05. So already we're assuming that there are some problems with the data, particularly the distribution of female scores. So let's move down and look at the histograms, which tell us quite a bit more. Now we know, looking at the Kolmogorov-Smirnov test, that the distribution for males is normal, and here we can see that the distribution looks pretty normal, so we're okay with that. However, when we look at the distribution for females, we can see that we have some negative skew. In other words, most of the scores, or a large proportion of the scores, are at the higher end of the range. In other words, females are scoring much more positively or highly in attitudes to homosexuality than males are. Males have a nice kind of even distribution there. However, for the purposes of this analysis, we're going to proceed with the Anova, because the practical that you're writing up is an exercise in Anova. So although we do have these issues with the data, you do report them at the beginning of your results section, but you also state that you're going to proceed with the analysis of variance. So now we've explored the data and we've recognised that there are some uneven group sizes and some non-normal distributions with regards to the females, we're going to proceed with the main analysis. So to conduct our between participants Anova, we're going to analyse general linear model, univariate. The first box that we come to is our dependent variable. So what we're going to do is add our total into the dependent box. And then the fixed factors are the independent variables, which are gender and age. So a couple of things we need to do before we go to the output, and that is we want to potentially create a line graph, because we might find an interaction. So we click on plots, we enter gender into the horizontal axis and separate lines for age. Add them to the box, continue. We don't need to conduct post hoc tests because we've only got 2 levels of each factor. So SPSS won't do the post hoc test for us. However, we can click on options, and by holding the shift button down and clicking on these independent variables, we can shift them across to display means for. Because one of the things that we're going to produce at the beginning of the results section, when we've discussed whether our data are normal or not, is a table of means. We're also going to compare main effects, so we're going to look at the mean differences in those scores between those independent variables, between gender and between age. And here we click on Bonferroni. We also click on descriptive statistics. Estimates of effect size will give us the partial eta squared, which tells us the proportion of variance that effect produces. We're also going to click on homogeneity test because that will produce the Levene's table. The Levene's table assesses whether our data meet or violate the assumption of homogeneity of variance. Click on continue, and I think we're good to go now, so we click on OK and move to the output. So the first box looks at the between subjects factors and gives us our group sizes, and here we can see when the groups are split further. For example, males and females in gender, we've got 36 and 90. For age groups, we seem to have far too many of the 18 to 29 years age group and not too many of the 30 plus. So again, this is emphasising the unequal group sizes. If we look at the descriptive statistics table, this is the table we'll need to produce our table of means at the beginning of the results section. And this would need to be produced in APA format. But here we can see that the means for males age 18 to 29, 48.19, females 18 to 29, 58.29, and so on and so forth. So in your table of means, you'll report the mean, the standard deviation, and the n in brackets. So here the n is 26, and so on and so forth. Moving to the Levene's table, we can see that the sig value for the Levene's table is greater than 0.05, which is what we need it to be to ensure that our data do not violate the assumption of homogeneity of variance. And in this case, our data do not violate that assumption, so we can proceed. So we've got something good happening with the data. However, the unequal group sizes are an issue. So what we move to next is our Anova table, and here we can see the main effects of gender is significant. The main effect of age is not significant, and the interaction between gender and age is also non-significant. So when we're reporting the Anova results in our results section, we don't include the Anova table. We just report the one-line F statistic. So what you'll report is F, open brackets, degrees of freedom. So for gender it's 1, 122, because we always report the error degrees of freedom. Close the bracket. The F statistic for gender, which is 14.06, and then our p-value which is less than 0.05. We'll also report the partial eta squared, which has a value of 0.1, which is a very low effect size. The same for age, so F, degrees of freedom, 1 and 122, RF statistic, and then we report that it is non-significant. Or we could say P equals 0.43, but we don't need to report the partial eta squared because we don't have a significant main effect. Then finally we report the gender by age interaction. Again, F, degrees of freedom, 1 and 122, equals 0.18, P equals 0.67. Again, we don't report the partial eta squared because it's not significant. So that's all we need to do in terms of reporting our results section. At the end of the results section, it's always good to summarise, because your research question was an exploration of gender and age differences in attitudes to homosexuality. And what was found was a significant main effect of gender. There was no further significance with our data, but also we need to make sure that we acknowledge that the group sizes were uneven. In your results section, you don't apply any psychological interpretation, you just report the figures and numbers and the means, the direction of the means. For example, with gender, if we look at the pairwise comparisons, we can see that males are 9 scores different or less than females. In other words, females are rating or are have a significantly more positive attitude to homosexuality than males do. But again, remember, you do have those uneven group sizes. Here we can see, looking at the line graphs that we produced, looking at males and females, we can see these points here are much lower. These are the means that represent the age groups for male, age groups for females, and we can see that there is a big difference here. It's not really necessary to include the line graph because you've reported the means. You would only include the line graph if you had a significant interaction. So that's how to run the analysis and to interpret the output. Just keep it simple and report what you need to report to complete your results section.